Welcome to Informatica Cloud 101 on-demand course. In this module, we are going to look at the Cloud Mapping Designer. After completing this module, you will be able to identify business use cases for the Cloud Mapping Designer. Use the Cloud Mapping Designer to build a mapping. Understand the different transformations that are available within the Cloud Mapping Designer, and validate and test a mapping. The Cloud Mapping Designer is an easy-to-use web-based interface for building end-to-end mappings. It allows the creation of flexible mappings to address more advanced use cases. You can think of the Mapping Designer as an alternative to using the data synchronization application for those use cases that cannot be handled using the application. The Cloud Mapping Designer allows you to perform more advanced transformation logic on your data. For example, you can do aggregations or create additional fields using an expression, or have a lookup return multiple values. The Mapping Designer can also execute the logic in a specific order. For example, filter data using the return value from a lookup. The Cloud Mapping Designer also allows you to create a mapping that includes multiple sources or targets. And you can actually join together heterogeneous sources. For example, you can combine data from a SQL Server database table with data from Salesforce in a single mapping. You can also write data to multiple targets. The other thing about the Mapping Designer is that you're actually able to parameterize elements of the mapping, which allows you to create reusable templates. All aspects of the mapping can be parameterized, including sources and targets, filter criteria, lookup conditions, and more. So there are two main use cases for the Mapping Designer. You can either do something that you can't do with the data synchronization application, or you can create a reusable mapping or template. What is a mapping? A mapping is an object created in the Mapping Designer. It basically describes the flow of data from a source or sources to target or targets. To create a mapping, you add transformation shapes to the mapping flow. These transformations perform various data transformation tasks. The other thing you can do is define field rules. Field rules are discussed in more detail in the Mapping Designer Part 2 module. At a high level, field rules define the fields that come into each of the transformations. These rules are criteria-based and allow for even more flexible mappings. For example, you can choose to include or exclude fields of a certain data type. This allows the mapping to remain valid even when new fields are added to the source. Then there are links that visually represent how data flows through a mapping. Now, before I show you how to use the Mapping Designer, it is important that you understand the life cycle of the mapping. When working with the Mapping Designer, the first thing you will do is design a mapping. Note that in order for a mapping to be valid, it must contain at least one source and one target. Then within your mapping, you can optionally create parameters for things like connections, objects, transformations, filters, lookup conditions, etc. Next, you will run and test the mapping in order to verify that the mapping works. If you have parameters in the mapping, you will be prompted to specify a value for each parameter so that the mapping can run. After the mapping has been validated, the last thing you will want to do is create mapping configuration tasks based on your mapping. Like other applications, mapping transformation tasks can be configured to run on a schedule or as a part of a task flow. They can also include pre- or post-processing commands. If the mapping contains parameters, the value for those parameters would be defined in the mapping configuration tasks. Mapping configuration tasks are discussed in more detail in a separate module. Here are some basic terminologies related to the Mapping Designer. When I refer to the mapping canvas, I am referring to the area where you will build your mapping. You will drag and drop shapes onto the canvas. Shapes represents source and targets as well as data transformations. The mapping is the end-to-end integration that you build using the Mapping Designer. When I talk about parameterized mapping, I'm referring to a mapping that contains one or more parameters. A mapping configuration task is an automatically generated wizard that allows you to configure a mapping including scheduling and parameter value assignments. If you make changes to a mapping, you can promote those changes to any dependent mapping configuration tasks by deploying them. Now there are some best practices we recommend for naming conventions. When you define a mapping name, you can use alphanumeric characters and underscores. A mapping name cannot contain spaces. You may want to consider using consistent naming conventions when you start using the mapping designer. These naming conventions can be applied to transformation names as well as field names. You may wish to consider using Informatica's implementation methodology, Velocity, as a guide for establishing your naming conventions. Velocity can be accessed by the Informatica My Support portal. Using naming convention now will better prepare you to leverage future functionality around additional repository management and searching. These are just some examples of the naming conventions you may use based on that velocity methodology. So sources can always be prefaced by SO underscore, targets with TG underscore, joiner with JNR underscore, etc. Also, when naming fields, consider identifying the source of the field by including the source name as a preface. So in addition to getting things set up for future functionality, naming conventions help you to easily identify the type of transformations used in the mapping. A transformation is a mapping object that either modifies the data in the mapping or passes it on to the next step of the mapping. A transformation as a mapping can either be active or passive. An active transformation has the ability to change the number of rows that pass through it. For example, a filter would be considered an active transformation because only the data that meets the criteria set in the filter condition would pass through the transformation. A passive transformation does not change the number of rows that pass through it. Let us talk about some of the transformations available in the mapping designer. The source transformation reads data from a source, and it is an active transformation. You can add one or more source transformations to a mapping. When setting up a source transformation, you will specify a connection and an object or objects. There are some advanced options based on the connection type. For example, when you select a Salesforce connection, you can use multiple related source objects and configure the Salesforce API Advanced Source option. You can also add or remove fields. So if there are fields you would not need downstream in the mapping, you can remove them from the source. You can also create an additional field if you need to pass additional data that does not reside in the source. The target transformation defines a target connection and target object for the mapping. When you configure the target, you will specify the operation to be performed. For example, insert, update, upsert, etc. You will also specify how incoming fields will map to the target fields. Depending on the connection type, there are some additional advanced options available. So for example, when you select a Salesforce connection, you can configure options for success and error log details. The filter transformation filters data out of the data flow based on a filter condition that you define. For each row of data, the filter condition returns either a true or false. If the return value is true, it passes the row of data on to the next step in the mapping. If the return value is false, the row will be dropped. It won't be passed on. When configuring a filter, you can include multiple conditions. In order for a row to pass through a filter with multiple conditions, all must be true. A filter transformation does not need to be linked to from a single transformation. You can't have multiple transformations coming into a filter. For best performance, you should place the filter close to the mapping source or sources to remove unnecessary data from the data flow. As I mentioned before, a filter transformation can change the row count, and so it is an active transformation. For the filter condition, you are going to define an expression that returns true or false. You can create one or more simple filter conditions, which would include the field name, the operator, and a value. Note that the conditions are case sensitive. You can use the following operators in the condition: equals, less than, greater than, less than or equals to, greater than or equals to, and not equals to. If you have more than one simple filter condition, they are going to be evaluated in the order that you specify. and are joined together using the AND logical operator. You can also use an advanced filter condition if you need to define a complex condition. So if you want to nest filter conditions or use an OR operator, you can do that with an advanced filter. When you create a mapping, it's a good idea to validate it. In order for a mapping to be valid, it needs to be complete and data must be able to flow from source to target. It is automatically validated when you save the mapping. After the mapping has been validated, the status is displayed in the upper right-hand corner of the mapping canvas. If the status is invalid, you can open the validation panel to review mapping errors. To open this panel, click the checkmark icon. After the panel opens, click the Validate button. Note that you must click this button to see the errors listed even if the mapping has already been validated by saving, for example. You can also click the error to view additional information about that error. After you have validated your mapping and the status is valid, you can actually run the mapping. This performs a test run of the mapping and should be done prior to creating a mapping configuration task. If there are parameters in the mapping, the wizard will prompt you to provide values for those parameters when you run the mapping. In this demonstration, I will create a simple mapping that reads data from the Salesforce opportunity object and based on the value of the amount field writes the data to two separate flat files, one for high-value opportunities and one for lower-level opportunities. In this demo, we will create a simple mapping with a source, filter, and multiple targets. Log into the Informatica Intelligent Cloud Services and select the Data Integration Service. To create a new asset, click New on the navigation pane. To create a new mapping, click Mappings on the left side of the New Asset window. Select the mapping option and click the Create button. We can see that a source and a target are already present on the mapping canvas. Specify the name of the mapping and click the New Source Transformation. In the General Properties section, for the name field, enter SO Salesforce. In the Source Properties pane, click Source and select the Salesforce connection from the Connection dropdown. Keep the source type as single object. And to select the source object, click the Select button. The Select Source Object window appears. Select Opportunity Object and click OK. And now we will add a filter to the mapping. Click the link joining the source transformation SO Salesforce and the target transformation New Target. To remove the link, click the bin icon and drag and drop the filter transformation from the list of available transformations onto the canvas. Link the source transformation SO Salesforce to the filter transformation New Filter. In the Filter Properties pane, under General Properties, enter the filter name as FIL Root High Probability Opportunity. In the Filter Properties pane, click Filter and keep the filter condition set to Simple. To add a new filter condition, on the right side of the Properties pane, click the plus icon. Enter the filter condition as shown on the screen. To configure the target for this filter in the mapping, link the filter transformation to the target transformation. Select the target transformation New Target and specify the name as TG High Probability Opportunity. To arrange all the transformations on the canvas, click the Arrange All icon. In the Target Properties pane, click Target and select the local CSV file connection from the Connection dropdown. Keep the target type as single object. Now to select the target object, click the Select button. From the Target Object window, select High Probability Opportunities.csv and click OK. In the Target Properties pane, click Field Mapping and click the Auto Match button to map the fields automatically. We will now add another filter to the mapping. Drag and drop the filter transformation from the list of available transformations onto the canvas and link the source transformation SO Salesforce to the filter transformation New Filter. In the Filter Properties pane under General Properties, enter the filter name as FIL Root Low Probability Opportunities. Click Filter in the Filter Properties pane and keep the filter condition set to Simple. To add a new filter, in the right side of the Properties pane, click the plus icon and enter the filter condition as shown on the screen. Now add one more target to the mapping. Drag and drop the target transformation from the list of available transformations onto the canvas and link the filter transformation FIL Root Low Probability Opportunities to the target transformation New Target. Select the target transformation New Target and enter the name as TG Low Probability Opportunities under the General Properties section. To arrange all the transformations on the canvas, click the Arrange All icon. In the Target Properties pane, click Target and select the local CSV file connection from the Connection drop-down. Keep the target type as Single Object and click the Select button beside the Target Object field. From the Target Object window, select Low Probability Opportunities.csv and click OK. In the Target Properties pane, click Field Mapping and click the Auto Match button to map the fields automatically. To save and continue working, click the Save button. We see that the mapping status is automatically displayed next to the mapping name. To run the mapping, click Run. Select the Active Secure Agent group from the Runtime Environment dropdown and click Run. To verify that the task has completed successfully upon the High Probability Opportunities.csv and Low Probability Opportunities.csv files. We see that the opportunities with probability greater than 70 are written to the High Probability Opportunities.csv, and the opportunities with probability less than 70 are written to the Low Probability Opportunities.csv file. This concludes the demo. The Mapping Designer definitely works best in Chrome. If you're using Internet Explorer, we recommend you that you use version 10 or higher. The Mapping Designer has known to experience display issues with earlier versions of Internet Explorer. Firefox has also been certified. Finally, use Save and Continue often to save your work as you're building your mapping. There is only one lab for this module. In this lab, you will build and run a simple mapping using a source, a filter, and multiple targets. This concludes Module 11. This module showed you how to use the Mapping Designer to build a mapping, use a mapping shape or transformations like source, target, filter, etc., and validate and run a mapping.